Question 35. A natural gas-fired power station generates electricity by reacting methane with oxygen. List in order the energy conversions that take place. So if we remember back to the beginning of the year, we had to look at what the energy conversions were in a coal-powered power station. So if we have a look here, we have the stages. So first of all, we've got the combustion of the fuel. So in our example, it was methane. The energy in fuels is stored as chemical energy. So this is our first energy. Then if we go back to our diagram, once that fuel undergoes combustion, the water turns into steam. So we've got chemical energy being converted to thermal energy. Okay, so once that thermal energy in number 2 has been water being converted into steam or turned into steam, that steam is then used to turn a turbine. So we've got our thermal energy being converted to mechanical, if I can spell, mechanical energy. Okay. Then that mechanical energy, the steam turning the turbine, then generates electricity. So our last energy conversion is into electrical energy, and that would get us 2 marks. The next question is B. Less electricity is generated by burning methane in a gas power station than if the same amount of methane was used in a fuel cell. Give one reason for this difference. So in our power station, we remember that its energy efficiency wasn't very high, and the main reason for this was because there was a lot of heat loss, okay, in that power station. Whereas when we have a fuel cell, we're turning our chemical energy directly into electrical energy. It's a one-step process, so we're not getting that heat loss. Okay, so that's why less electricity is generated, because there was more stages, because we're turning that chemical energy into electrical energy, but along the way we've got heat loss. Whereas in a fuel cell, we're going directly from chemical energy to electrical energy. The very last question. State one factor that limits the widespread applications of fuel cells to generate electricity. So if you remember in class, we looked at catalysts on those electrodes in our fuel cells, and they are predominantly using a platinum catalyst. They're quite expensive. Okay, so that's one factor that would limit the widespread application of our fuel cells, just the expense of the fuel cells themselves.